Okay, so today, since the revision, general solutions, since most of you didn't perform well in this section, so I thought we should revise a bit. Season. Okay, so njengamanje I've distributed the worksheet in the different kinds of different general solutions. Exobe late. That is Kasonya. All right, so in your worksheet here, we have number 1. You can see number 1, it's 5 over 2 sine into 90 plus x sine x, which minus 5 root 3 over 8 equals to 0 for 5 marks. You want to solve the general solution for this one. So anyone who have an idea how to approach this one? That should be our first step. First step. Yes. We expand this one. I disagree. You should expand using compound. I disagree. Yes. We reduce this. We can recognize the sine 90 plus x. Okay. So this is 5 over 2. Then if you reduce this will be cos x, since it's in the second quadrant and sine is positive in the second quadrant. So you get a mark for doing that. Then it's sine x is equals to, then I propose we take this constant to the other side. At the same time, it will change the sign. The sign will now be positive. So we have root 3 all over 8. And then our next step. What should be our next step? Yes. Multiply across by 2. So if we do that, we'll have 5 cos x sine x is equals to, if we multiply this by 2, what will happen? You'll have 5 root 3 over 4, because you'll have to divide there. Okay, and then after that, we recognize this though. So what is missing? 2. So how do we make sure that we have a 2 here as a coefficient? I propose first we get rid of 5. How can you get rid of 5? Divide by 5 both sides. So let's do that. So if you divide by 5, this will cancel. Then now you'll be left with sine x. If I were to rearrange this term, which is cos x equals to, then if you divide by 5, this will become root 3 over 4. And then multiply by 2. So if we do that, we are going to have multiply by 2 both sides. We manipulate so that we have 2 sine x cos x equals to, then our right hand side will be root 3 over 2. And then we apply the double identity for sine. So this term will become sine 2x equals to root 3 over 2. And then from here, reference angle. What will be our reference angle? It's 60, Then it's 60 degrees. And then from here, we go on and find our general solution. So, which quadrant? First quadrant where sine is positive. So our first solution will be in the first quadrant. So in the first quadrant, we say 2x, which is the angle, is equals to 60 plus, since we are looking for a general solution, plus k times 360, where k is an element of integers. And then how do we solve this? Remember, we are solving for x. Divide by 2. So this is x equals to 30 plus k times 180. We divide everything by 2, where k is an element of integer. So this is our first solution. Then our second solution will be in which quadrant? Second quadrant. So it's in the second quadrant. So this is 2x equals to, then in the second quadrant, how do we write angles? 180 minus. So it's 180 minus the reference angle, which is 60. Then we say plus k times 360, where k is an element of integers. And then from here, what is this? This is 120. We agree, yeah? This is 120. Then we divided 120 by 2, which means it will be 60. So it's 60 plus k times 180, where k is an element of integers. Then this will be your two solutions. And then how many marks for this? 5 marks. Then you'll have the mark for this step, okay? Then you get your 5 marks. Okay, any questions? Any different approach? Okay, we move on to number 2. Number 2, we have, in number 2, we have 3 cos 2x plus 5 cos x is equals to 1 for 7 marks. So how do we approach this one? We change cos 2x. But then as we change cos 2x, you need to remember that you need to introduce the brackets, because these 3 will have to distribute. So where? 2 cos y. Why are we choosing 2 cos squared minus 1? Because we have this same. We want everything to be expressed in terms of cos. So this is 2 cos squared x minus 1 plus 5 cos x. Then let's take this one to the other side. So equals to 0. Because everyone can see we are going quadratic. Yeah? So this will be a quadratic equation. And then from here, we distribute. So if we distribute, we have 6 cos squared x minus 3 plus 5 cos x minus 1 is equals to 0. And then from here, like terms, standard form. So our standard form will be 6 cos squared x plus 5 cos x minus 4 is equals to 0. Then you need the factors for this. You need to factorize this, or you can use the quadratic formula in order to get the root. All right. So what will be the factors? 2 cos x. Then we have 3 cos x. Then this side will be minus 1. Then this one will be plus 4. Does it check out? Yes, it does. Because we have, yeah, it does. And then from here, then you say, then what will be the solutions? Cos x is equals to 1 over 2, or cos x is equals to negative 4 over 3. Then what do you know about this solution? This solution, we have to reject this solution, because we know that the graph of cos, it's between 1 and minus 1, and this is below minus 1, because it's negative 1 point something, which means it's here. So for this one, we have no solution. Even if you punch it in your calculator, if you are looking for a reference angle, the calculator will tell you it's an error. So we are only going with half. So what will be the reference angle of this? 60 degrees. And then which quadrant? First quadrant. Then we know in the first quadrant our solution will be 60 plus k times 360, where k is an element of integer. Then our second solution will be in the fourth quadrant. And in the fourth quadrant, we say 360 minus. So what is 360 minus 60? 300 decrease plus k times 360, where k is an element of integer. So these will be the two solutions that we have for this one. How many marks? 7 marks. So it's 1, 1. Then it's 1 for this step, 1 for this one, 1. Then for changing there, yeah, 1, 2, 3, 4, 5, 6. Maybe the other mark will be allocated for restricting the other solution. Okay. Questions? No questions so far. Okay. Then let's go to number 3. Let's go to number 3. Number 3, we have 4 sine. This is number 3. We have 4 sine squared x minus sine x. And then we have equals to cos 2x plus 1 for 7 marks. For 7 marks. How do we approach this one? Change cos 2x to 1 minus, because we want everything to be expressed in terms of sine. So let's go and do that. So this is 4 sine squared x minus sine x is equals to, then you say we change this to sine. So it's 1 minus 2 sine squared x plus 1. And then our next step, standard form. Then if you take this negative 2 sine squared to the other side, you'll have what? 6 sine squared x. And then we have minus sine x. And then what will be the constant? Minus 2 is equals to 0. This will be the standard form. Where do we get minus 2? This is 2, then you take it to the other side. Okay, and then we look for factors. Do we have the factors for this? What will be the factors? 3 sine x minus 2 into 2 sine x plus 1 is equals to 0. Since I trust you, I won't check this side. But if you multiply, let me check. Yeah. Okay, then yeah, correct. And then what will be our next step? Then our next step will be to solve. So this is sine x equals to 2 over 3, or sine x is equals to negative 1 over 2. Okay. What is the reference angle for this one? 41,81. Round off to 2 decimals. Then let's go ahead and find the solution. First quadrant. The solution for the first quadrant is going to be x equals to 41,81 degrees plus k times 360, where k is an element of integers. And then our second solution will be, because it's in the second quadrant, so if you say 180 minus this, you are getting 138,19 plus k times 360, where k is an element of integer. So these are the two solutions we are getting from that branch. What about this one? The reference angle. The reference angle is third. Then which quadrant are we operating in? Third and fourth. So this is x equals to, in the third we say 180 plus. So if you say that, you have 210 degrees plus k 360, where k is an element of integers. And then our second solution is in the fourth quadrant, which means 360 minus 30, which will give you 330 plus k times 360, where k is an element of integers. And then you get your 7 marks. This will be 4 marks. Then for changing, then you have your 7 marks. Okay. Let's go to number 4. What is happening in number 4? What is happening in number 4? Number 4, we have cos x, cos 35 minus sine x, sine 35 minus sine x is equals to 0. We are finding the general solution. So what should be our first step? We collapse. You can recognize that this is a compound angle for cos. This is a compound angle for cos. So if you were to look at this as if this is A, this is B, this is A, this is B, then you go to your formula sheet, you'll see that this will go to cos into A, it's X, plus, since it's cos, you're going to say plus 30, plus 35. Then, or we take this sign to the other side. So we have negative sine, we have positive sine X. And then from here, we change using correlation because we want everything to be expressed in terms of cos. Okay? Because you cannot divide by cos both sides since the angles are not the same. So we have to change this to go to cos. How? By introducing a 90. Okay, so now this is cos into X plus 35 is equals to cos into 90 minus X. So now everything is expressed in terms of cos. So this will be the reference angle. This will be the reference angle, which is 90 minus X. Okay? And then from there, you have, and then from here, we look for solutions. We look for solutions. So this is X plus 35. Since it's the first quadrant, since we are positive, cos is positive in the first quadrant. Okay? So in the first quadrant, we take it as it is, minus X plus K times 360, where K is an element of integers. Then from this step, it's all about knowing your algebra. Then from here, what will you have in our left? 2, because if you take this minus X to the other side, we have 2. We have 2X equals to, take this to the other side, we have 50. 55 degrees plus K times 360, where K is an element of integers. And then we divide by 2. Okay, so if we divide by 2 across, we have X equals to 27,5 plus K times 180, where K is an element of integers. Then we look for the second solution. Where will you find our second solution? In the fourth quadrant, where we'll say 360 minus 90 minus X. So that is 360 minus into 90 minus X plus K times 360, where K is an element of integers. This is what we will have. And then from here, we distribute. So let's go and do that. This is X plus 35. This is 360 minus 90 plus X plus K times 360, where K is an element of integers. And then what will happen to X? It will cancel out. So we'll have 0. So 0 can never be equals to, what is 360 minus 90 minus 35? 235 degrees plus K times 360, where K is an element of integers. So you say no solution in this one. Okay? Everyone okay? Yeah, there's no solution for this one, so we are only going with this solution. All right. And then we go to number 1.5. Number 1.5, you have 4 sine 2x. Sine 2x is equals to 3 tan x. And then you have plus 2 sine x. What should be our first step? Change tan. Okay. So we have 4 sine 2x is equals to 3. So what will be tan? Sine x over cos x. Cos x plus 2 sine x. And then change this one. Okay. So we have 4, which will become 8. So this will be 8 sine x cos x, because of this 2, it will be 8. Okay, equals to 3 sine x over cos x plus 2 sine x. And then sine by cos, which will give us 8 sine x cos squared x is equals to 3 sine x plus 2 sine x cos x multiplied by cos x. Thank you. Cos x. And then from here, standard form. Let's take this to the other, everything to the other side. So we have 8 sine x cos squared x. You agree, yeah? Then let's take this term, which will be minus 2 sine x cos x minus 3 sine x equals to 0. And then what are you observing at this stage? Common factor, very good, common factor. So our common factor will be sine x. Sine x. So it's sine x as the common factor into 8 cos squared x minus 2 cos x. Yeah? Minus 3 is equals to 0. Do you recognize what is inside the bracket? That is quadratic. Eh? So that means we have a solution that says sine x is equals to 0. Eh? And then we have another solution that is the factors of this. What are the factors of this? What are the factors of this? It's 4 cos x minus 3. Okay. Then into 2 cos x plus 1 is equals to 0. Did you check? It's checked out. Okay. And then from here, we make cos x the subject of the formula. So since cos x is the subject of the formula, this will be 3 over 4, or cos x is equals to negative 1 over 2. So that means we have to find all the solutions for these three. Yeah? But in an exam, you'll find that maybe they'll say cos x is greater than 0, which means you won't be required to find the solution for this. But now, since we don't have the restriction, so let's go ahead and find the general solutions for this one, for all three. For all three. All right. So let's start with the one that says sine x equals to 0. So the reference angle will be 0. Then our solution, we treat 0 as positive. So this is x equals to 0 plus k times 360, where k is an element of integers. And then our second solution will be 108. 180 plus k times 360, where k is an element of integers. Now let's go and find the solution for cos x is equals to 3 over 4. Cos x is equals to 3 over 4. Reference angle 41, comma 41 plus, this is a reference angle. Then we are in the first quadrant. So this is x equals to 41, comma 41 plus k times 360, where k is an element of integers. Then the other solution will be in the fourth quadrant. Then you say 360 minus this. What are we getting? 318, comma 59 plus k times 360, where k is an element of integers. Now we are done with cos x equals to 3 over 4. Now we are dealing with cos x equals to negative half. So this is cos x equals to negative 1 over 2. We said the reference angle is going to be 60. Which quadrants are we operating in? Second and third. In the second, we say x equals to 180 minus 6, which is 120 plus k times 360, where k is an element of integers. Then the other solution will be 240, because we say 180 plus 60 since we are operating in the third quadrant. So this is 240 plus k times 360, where k is an element of integers. Please do not forget k is an element of integers, because you won't get a mark. All right. So this was number 5. What about number 6? What about number 6? So let's do number 6. Let's do number 6. Okay. Number 6. Number 6, you have 3 sine x minus 3 root 3 cos x is equals to 4. So what should be our first step in this one? Take out 3 as a factor. Okay, or should we divide by 3 across? Okay, divide by 3 across. So if you divide by 3 across, you'll have sine x minus root 3 cos x is equals to 4 over 3, because you are dividing everything by 3. And then this is the expression that you recognize, I think. So we need to manipulate that expression. How? Multiply by half. We multiply by half. So we multiply by half. So if we do that, we have half sine x minus root 3 over 2 cos x is equals to, if you multiply this by half, we have 2 over 3. If you multiply this by half. Okay? And then from here, you're going to sine. So this is sine x, then this will be cos, cos 60. Minus, if you like, you can go to cos, but let's choose sine. Okay, sine x cos x, then we have cos x, this cos x, then this is sine 60. If you punch in your calculator sine 60, you'll get this. If you say cos 60, you'll get half. So this is equals to 2 over 3. And then from here, we collapse. So this is sine into x minus 60 is equals to 2 over 3. And then from here, reference angle. What is the reference angle? 41,81. 81. Then our first solution is in the first quadrant. So we have x minus 60 is equals to 41,81 plus k 360, where k is an element of integers. And then if you solve this one, x will be 101. X is equal to 101,81 plus k times 360, where k is an element of integers. And then our second solution, what will be our second solution? Second quadrant. So in the second quadrant, we are going to say x minus 180. You're going to say 180 minus 41,81. Then you say plus 60, which will give you 198,19. Then plus k times 360, where k is an element of integers. This will be the second solution. And then you get your full marks. Okay? All right. And then we have number 7. Number 7. Okay. Number 7 looks complicated, but I trust you. Okay, let's go into number 7. So this is 2 sine 3x minus 2 cos x. Cos 2x. Cos 2x sine x is equals to cos x. Find the general solution. So what are you proposing as our first step in this one? We rewrite this. Okay, we rewrite this as 2 into sine into, this one should be a square bracket, into 2x plus x, minus 2 cos 2x sine x equals to cos x. And then from here, we expand using compound for sine. So this will be 2 into sine the first angle, cos the second angle. And take the sine as it is, cos the first angle, then you sine the second angle. This is negative 2 cos 2x sine x is equals to cos x. And then distribute by 2. Very good. So if we do that, we have 2 sine 2x cos x. And then we distribute again by 2. We have plus 2 cos 2x sine x. Then we have minus 2 cos 2x sine x is equals to cos x. Yeah? Cancel. We have like terms. So these two are like terms. We cancel them out. And then we only have, now left we have 2 sine 2x cos x. Then on the right hand side we have cos x, which means we should take this one to the other side. So let's do that. We have 2 sine 2x cos x minus cos x is equals to 0. Then from here, common fact. What is the common fact? Cos x into 2 sine 2x minus 1 is equals to 0. And then from here we are through. So this is cos x equals to 0, or sine 2x is equals to 1 over 2. Once you have this 1 over 2, then you go and find your general solutions. So the reference angle is going to be 90. The reference angle is 90. So we treat 0 as positive, which means first quadrant we will have 90 plus k times 360, where k is an element of integers. Then our second solution will be 270, because we say 36 minus 90. So it's 270 plus k times 360, where k is an element of integers. What about this one? What about this one? What about this one? Reference angle is going to be 30, and then the first quadrant, 2x equals to 30 plus k times 360, where k is an element of integers. Then x is equals to 15 plus k times 180, where k is an element of integers. And then we have another solution in the second quadrant, which means it's 2x equals to 180 minus 30, which is 150. 150 plus k times 360, where k is an element of integers. Then you divide across by 2, which will give you 775 plus k times 180, where k is an element of integers. Then you get your 7 marks. Okay. Question? Yes. Yeah. Divide by cos. Okay. Which means if you divide by cos, you'll get rid of this solution. You won't get full marks. If you divide by cos, you get rid of this solution. You won't get full marks. Like for instance, let's say you have x squared is equals to x. If you divide by x, you get rid of the answer that says x equals to 0. Because if you solve this one, you say x squared minus x is equals to 0. Then you factorize. X minus 1 is equals to 0. Then your solution is x equals to 0, x equals to 1. But if you divide by x, you'll have x equals to 1. You'll only have one solution. See what? So it's important here we factorize. Very good question. All right. And then we are going to number 8. Okay, let's go and see number 8. What is happening in number 8? Let's see. What is happening in number 8? Number 8, we have cos 60. Cos into 2x plus 30 is equals to sine x cos x. Sine x cos x. What should be our first step? Change the special angle. Cos 60, 1 over 2. Then we have cos 2x plus 30 degrees is equals to sine x cos x times by 2. Then you have cos into 2x plus 30 is equals to 2 sine x cos x. And then we collapse this. Okay, so we have cos into 2x plus 30 is equals to sine 2x. Sine 2x, this is a double angle for sine. And then from here, change this one to cos by introducing a 90. We are using co-ratios in reverse. Okay, so this is cos into 2x plus 30 is equals to cos into 90 minus 2x. Then this part becomes our reference angle. Then we have reference angle is equals to 90 minus 2x. We put this right, right. All right. And then from here, we solve. This is the first quadrant where cos is positive. Okay, so we say 2x plus 30 is equals to 90 minus 2x plus k times 360, where k is an element of integers. And then in our left hand side we'll have 4x. We'll have 4x equals to 60 plus k times 360, where k is an element of integers. And then from here, divide by 4. So this is x equals to 15 plus k times 90, where k is an element of integers. Our second solution is in the fourth quadrant. So we have 4x plus 30 is equals to 360. You said 360. Oh, it's 2x. Oh, sorry. It's 2x is equals to 360 minus into 90 minus 2x plus k times 360, where k is an element of integers. And then we have 2x plus 30, and then we distribute. So this is 360 minus 90 degrees plus 2x plus k times 360, where k is an element of integers. And then what will happen to x? It will cancel out. Then we know that 0 can never be equals to 360 minus we are getting to 240. 240 plus k times 360, where k is an element of integers. Then you say no solution for this one. Okay, now we are doing 1.9. 1.9. 1.9. Questions? No questions. All right. Okay, we have one. Okay, yes, mister. What's that? No solution. Yeah, I don't think they will penalize you if you are skipping this step. Yeah, then you say no solution. I don't think they will penalize. But then, what will it hurt you to write this step? No. All right. All right. Okay, let's go to number 9. 1 minus tan x is equals to cos 2x. What should be our first step in this one? Change tan. Okay. So we have 1 minus sine x over cos x is equals to cos 2x. Since you are quiet, I'm bringing back cos 2x. Where are we changing cos 2x to? Sine. Why sine? Why 1 minus 2 sine squared x? Because this will cancel out to 1. Very good. So we have 1 minus sine x over cos x is equals to 1 minus 2 sine squared x. And then 1 is out. We don't have 1 anymore, which means we are only remaining with sine x over cos x is equals to negative 2 sine squared x. And then from here, times by negative cos. Times by negative cos. So this will be sine x is equals to 2 sine squared x cos x. Should we divide by sine x? No, because we are getting rid of this solution. So we take this, or we take this to the other side. We have 2 sine squared x cos x minus sine x equals to 0. And then we take out common factor. So what will be our common factor? Sine x. So sine x into 2 sine x cos x minus 1 is equals to 0. Then we apply the 0 law. So we have sine x equals to 0, or what is this? Sine 2x. Sine 2x equals to 1. These two will go with the double identity. Then we'll take 1 to the other side. Then the reference angle for this one, it's 0. Okay, let's find the general solution here. So since it's 0, so we have x equals to 0 plus k times 360, where k is an element of integers. Then our second solution will be 180. So it's 180 plus k times 360, where k is an element of integers. Now we are looking for a solution for this one. So this will be, reference angle will be 90 degrees. And then the subject of the formula is 2x. Then the first quadrant, since it's positive, then we say k times 360, where k is an element of integer. Then we divide across by 2, which will give us 45 plus k times 180. Very good. 180. Since we are dividing everything by 2. Very good. And then another solution will be 180 minus 90, which will still have 9 there. So there is no need for finding that one. Yes. This one. Yeah. Yeah, this one. Yeah. But then the problem is that graph maybe domain will be restricted to 0 to 360. But this one will give you a general solution. So you graph, unless if you graph until leave it infinite. But this one accommodates every solution since we are finding the general solution. But then we are raising an important point. Let's say in this question they said, where solve for x, where x is an element from 0 to 360. Let's say we have the same question, then they say where x is they give you this domain. So what will be the solutions that will be accommodated here? Will we take 0? Yes. We are taking 0. We are taking 0 from this one. If we substitute 0 here, remember k represents the integers. What will be the second one? It's 1/8. Someone is saying 1/8. If you introduce 0, it will be left with 1/8. So we are taking 1/8. We are taking 180. Then the others are saying we are taking 45. 45. Do you have another one? If we put 1 here, we'll have 225. Okay. Do you have another one? Do you have another one? 90. Or 90 if you're letting this to be equals to 0. So you also have 90. Okay? Yeah? And 360 is included. So where are we going to find 360? Or if we are letting this equals to 1, yeah, very good. So this is 360. So yeah. So let's go general. Okay. And then yeah. Okay. Now let's go into number 10. Yeah, in number 10, very good question. Then number 10. Let's do number 10. There was a clock here floating around it. Okay, thank you. Alright, so number 10, we have 3 over 2 sine squared x minus 1 over 2 sine 2x minus cos squared x is equals to 0. What are you proposing for this one? We change sine 2x. Okay, let's do that. We have 3 over 2 sine 2x minus 1 over 2 into 2 sine x cos x. Minus cos squared x is equals to 0. Yeah? And then from here, we multiply here. Let's multiply here and see what happens. So this is 3 over 2 sine squared x minus, this will cancel. Then we'll be left with sine x cos x minus cos squared x is equals to 0. Get rid of the fraction. Times by 2. 1 over, so times by 2, yeah. You have 3 sine squared x minus 2 sine x cos x minus 2 cos squared x is equals to 0. Do you recognize this quadratic? You recognize this quadratic? So this quadratic is the same as the one you were doing in grade 10. That will say 3x squared minus 2xy minus 2y squared equals to 0. Then you were able to factorize this. Okay. So what will be the factors? The best way to do this is to ignore y. Ignore y. So what will be the factors? What will be our factors? What will be the factors? You don't have factors. Macom, no problem. Even if we have commas. So now let's say we are getting commas. Are you sure? Okay, let's check. We multiplied by 2 across, and this became a 2. This also became, we have a 3. Then if you find, okay, let's move forward. So we are saying we are getting commas, which means we have sine x equals to, okay, did you agree that this is going to tan? Or we should adopt this method. There is another method which was proposed by Mr. Ndelu, who is doing, I think, computer science in UCT. In this problem, he said we can divide by cos squared. If you divide everything by cos squared, let's try and do that. What will happen if you divide by cos squared in this term? This will become tan squared x minus. We are dividing this term by cos squared x. This will cancel out. Then we'll be left with 1 cos in the denominator, then which will become 2 tan x. 2 tan x. Then minus 2 minus, if you divide by cos squared x, this will eliminate. This will be eliminated. Then we have this. Okay? Yes. No, it won't, because we are allowed to divide by cos. Remember in grade 11, there was a general solution where if we divide by cos, then it goes to tan. If you divide by cos, no, it does. If you are going to tan, though. But if you are cancelling it out, like in this problem, no. Very good question. And then from here, then give me those solutions which are commas. So we have tan x equals to, we are using quadratic formula. tan x equals to 1 comma 1,22. But then you don't remove that in your calculators, because we don't want to round off, because we round off to the final in the final answer. All right. Or tan x is equals to negative 0,55. Okay, no problem. Don't worry. Okay, and then what is the reference angle for this? What is the reference angle for this? Yes. Here. Okay, so at this time it's divided by cos squared x. Cos squared x. Okay. So if you divide by cos squared x, you will have 3 sine squared x divided by cos squared x, which will be tan squared x. You agree? In the second term, remember we are dividing by cos squared x. So if you do that, this cos will eliminate. Then you'll have 1 cos remaining in the denominator. Then you'll have tan. And then this will cancel out. Then you are here. Okay, what's the reference angle? 50, comma 66. 55. If you didn't round off, Okay, so this is 55. 55. Then the nice thing about tan is that we only look for one solution. So this is x equals to 50,55 plus k times 180, where k is an element of integers. Then now what about this one? 28. So x is equals to 20, or reference angle. So reference angle is equals to 28, comma 75 degrees. And then in the second quadrant, then this is x equals to what is 180 minus 28, 75. 151,25 degrees plus k times 180, where k is an element of integer. Yeah, very good. This one, very good. So if it doesn't factorize, then you have another 2. You have to divide by cos squared x, which will go to quadratic. All right. Then we are going to the last one. So the last one. Let's do the last one. Okay. So the last one. We have sine into x plus 30 plus 1 over 2 sine x is equals to 5 over 2 cos x. Cos x. What do you propose in this one? What should be our first step? Remember, this is the last one. It's a higher odd. We expand the first term. Okay, let's do that. So this will be sine x cos 30 plus cos x sine 30 plus 1 over 2 sine x is equals to 5 over 2 cos x. And then someone is saying evaluate the special angles. Okay, so this will be this is root 3 over 2 sine x plus half cos x plus half sine x is equals to 5 over 2 cos x. Multiply everything by 2. Okay, very good. So this will be root 3 sine x plus cos x plus sine x is equals to 5 cos x. Then we add the like terms. Okay, so okay, this one is going to tan. I don't know if you can recognize it. This one is going to tan. Okay, so let's take the terms for cos to the other side. So this is root 3 sine x plus sine x is equals to 4 cos, 4 cos x, if you take this one to the other side. And then how do we add this? Who have a method for adding these two? Take out sine as a common factor. Take out sine as a common factor if you want to avoid irrational numbers. So let's take sine x as the common factor, which will give us root 3 plus 1. This is the coefficient, or if you like, we can even write it like this. We can have root 3 plus 1 sine x. Okay. Then this is 4 cos x, and then we divide by cos. So if we divide by cos, what will happen, Mr. D? If we divide by cos, this will become tan. So you have root 3 plus 1 tan x. Tan x equals to 4. This will cancel out. And then what? Tan x is the subject of the formula, and then we have 4 over root 3 plus 1. Then you can give me in the rationalized form, which will be rationalized form 2 plus negative negative 2 root 3, like this. All right, no problem. Okay, let's use this one. It's fine. So x, the reference angle is going to be, the reference angle is 55, 67 degrees. Then let's go and find the solutions. The solutions will be x equals to 55, 67 plus k times 300i, 180. Since we are dealing with tan, where k is an element of integers. Any questions? No questions.